Welcome to our class. We continue with our lessons now, and today we're looking at how to build a web app with the Noir. So I'll be taking you through those steps, and at the end of the class, you can also try it and see that it works. Now, so what we will learn in today's lesson, one, we learn how to build a web app with the Noir JS. And then we will show the steps of how to set up dependencies. That's one of the things we'll be doing. Then write a simple, just a minute. Then write a simple Noir circuit, compile and integrate it into the web app, then connect to Barretenberg for zero knowledge proofs, then interact with the app in the browser. So those are the steps I'll be taking you through. You don't require any other requisite like math or so on. You only require Noir to install and the required dependencies, and then we proceed. So first, just to remind you what Noir.js is. Noir.js is a TypeScript package that is used for running Noir circuits in browsers or servers. Now, it has several roles. One is to let you create, execute, and then verify zero knowledge proofs with ease. And then the other one is that it works together with the Barretenberg. That is the Aztecs ZK backend. So today we'll be using it together with Barretenberg to create a privacy-preserving web app. So this is just the first of these classes, creating a web app. But then from here, we will again be revisiting the same knowledge until we are familiar with it and until we can create complicated circuits. But today we'll be looking at just a very simple circuit. But the main thing is, can we integrate it in our browsers? So that is the main goal. So what we need to have to install is a Node.js. That's one of them. So if you have this PDF, if you click on this blue thing, it's clickable. It must direct you to, it will direct you to where to download. But you can also write a link or just search for it and then download it, install it. You can also install Yarn, and you're using Yarn package manager for this. You can also, if you don't have Nago, of course, most of you have it. But if you don't have it, then you need to install it. This is not the latest. So this is a V1.00 beta 2 is not the latest. The latest now is a beta 10. But what I've said is that this would then work with from this version going forward. So, and I've already said the current version currently is beta 10. So, but you can install even this one. Can install this one? It's no problem but it will work from this version going forward. Now, if you want to know more about installation, then you can visit Noir installation guide, and it has most of this on how to install any of this. Now you can install this BBJS 084, and how to install it is here. Although it's not the most current, but this is this example I did using this. I used this to do this example, but it's not the current. So you can always look for the current and then install it. Now, just about the packages I've said we need to install them for us to do what we are supposed to do today. Noir.js. This is the main Noir package, and its function, as I had already stated, is to run circuits and generate witnesses. bb.js, its function, and I've said earlier, it's a TypeScript interface for Barretenberg, and its role is to do ZK proving and verification. And of course, we've been interacted with this before. When we have been doing our circuits earlier, whenever we wanted to do proofs and verification of proofs, we used it. So something that we are very much familiar with. Now, both these two, Noir.js and BB.js, they use WASM to run in browsers. And therefore, this is what we'll be seeing. This is what we'll be doing. And of course, you need to do it step by step so that you understand. So we begin by creating a circuit, just the normal way we normally do. So these steps of creating a circuit, we are all familiar with it because it's something we've been doing. So to create a circuit, for instance, if you are working with the WSL, you would say first of all, you CD where you store your programs, your Noir programs. For me, I store them under Rust programs. So all my programs, I store them under Rust programs. So the CD Rust programs. Then while there, I would make the circuit that we want to use today. And today, just be showing you the commands and not be doing it using my VS Code or WSL. But in the next class, we will then look what now I'll be doing it practically. But today, I'm just showing you the codes. So once you are where you store your programs, let's say it's Rust programs like me, you would make a directory p circuits /src, and then touch circuits /src/main. So you're creating main also .nr, and then circuits /nago .toml. Now, you don't need to do all this this way. There are various ways we've been doing it, and you can always use all those ways. They still work. But this is just another way you can do it. After that, the simple circuit I want to use is this. This is a simple circuit just to force somebody to prove that is above 18 years. Now, what you notice by this circuit is that age here is private, is not public. So it's only the prover who knows what age he is. But he wants to prove to the verifier that is above 18 years and does not want the verifier to know the age he inputs or she inputs. Okay, so we'll come to that again when we get the browser. We'll be seeing how it works. that is only the prover who knows the edges, and the verifier does not know. So you will add this, we know how to create our nagotomil. Of course, this is not complete, but we know we've been doing this. Now, if you want to compile this circuit, you'll want to do CD circuit, nago compile, then it compiles. Now, when it compiles, we know that target is created, and inside that target, we have circuit.json. And this is very important because it's what we want to be able to run in our web app. So we require this circuit.json. Now, so for us to set up the web app, we just want to keep it simple, nothing complicated, because this is our first class on web app, so it must be simple. So we would create files using touch index.html, index.js. So you're just running this in your terminal, and then it opens where you need to write something. When you run that in the terminal, it opens where you need to write something, and what it opens, you add this. Of course, it's opening HTML, and you paste this inside that. Just copy this and paste inside that. Now, so next time I'll be telling you what each of these means, but when you look at it, of course, you can see there's edge, submit, enter edge, module, index, input, error, edge, number, and so on. So I'll be telling you what all these mean. But for today, just you copy this code. Once you say touch, once you run this in the terminal, touch index.html, index.js, and of course, you note where the spacing, it opens where you have to paste this. So you just copy this and paste. It is a long thing, it goes up to here. So you copy and paste it. Now we want to create another folder, and we call it index.js. And of course, when you run that touch, you just run it, it opened these two. So you just, again, copy this and paste it inside the index.js. So I just want you to see what we are pasting. Inside index.js, you are pasting this. Then inside the HTML, we are pasting this. Now we have those two. So up to where we've reached, your folder structure should be this way. So you have the title, you have circuit, SRC. Inside SRC, we had our simple main.nr, We have Nagotomil, target, and we've just added these two, and we have showed you what to paste inside. And then you can create a package.json, or this one we can create automatically by running a yarn command. I'll give you that, but we've had it before, we've used it before, so we know how it is. But this is the structure we're supposed to be having up to now. So what follows is just to improve on the codes we have, just to add a few things here and there to those codes, so that now we can directly connect what we are working on our local machine to the website. So we now want to import Noir.js. Of course, we said how important it is. So at the top of index.js, we paste this. We paste this. So you see, we had already pasted something. So I'm just saying at the top of it, you would still paste this again. Yeah, these are just 3 lines to import Noir.js. So the first line imports Barretenberg backend for proofs. The second line would then import Noir.js, which runs the circuit. And the third line would then load your compiled circuit. From JSON file, after you run Nago compile, every time you run Nago compile, it does that. So these are the roles of these 3 lines. We're just pasting them at the top to do the importation. So this slide is just showing you where to paste. It's showing you where to paste that. Let's just go back. And I look at this index.js. So we have this block. Begin with the try. And then here I've put backslash. Noah goes here. So I've said Noah goes here. So this is where we will paste Noah. So that is what you're seeing here. I've said try, then try. Inside here, we are pasting something. When you go above, there was nothing. There was nothing inside the try. And we said now Noah goes there. Now, so when you paste this here, when you paste it here, just copy and paste it in your index.js. This was blank, and I'd left this blank for that. So what this does is that it sets the circuit and the proving backend so that you can run and prove your program. So this command here, this command, copy and paste it there, and that is what it does. So that after you've done that, this is now how your index.js is supposed to look like. Remember, we did post 3 lines above, so they are here. Those 3 lines are here, the one we pasted above. And then inside try, this from here up to here, I'll paste this. And there's some code left, we will put more code. So I'm just putting bit by bit so that you understand what every bit does before we paste it. Otherwise, we would have put the full content, but then doing that, you will not have understood what every bit does. Now, for you to now execute and prove, there's another code here that we need to add. And I've said on button click, get edge input. So what this will help is that once you are online, you've been required to input your edge, for instance, so that you can prove it and so on. So this is the command that assists, that will be assisting you to get a space, for instance, to input your edge and then prove and so on. Now, so inside the index.js, we had some space left. I decided some code coming there. So this is the code we are copying and then pasting it there. Just show you. After inserting this, I said the rest of the code goes here. So now, the one I'm just showing you is supposed to come here, therefore. So all this goes in the try block. And this code, the importance I've already said, is it runs when the user clicks the submit edge button on your web page. So when the user clicks submit edge, this is the code that then runs. Now when it runs, it does two things. One, it runs your Noir circuit with the edge from the input box and it gets a witness. Of course, you require that witness. And then two, it uses Barretenberg to make a zero knowledge proof, which with that witness, so using that witness, it then makes a zero knowledge proof. And this should be verified later. This zero knowledge proof should be verified later. So maybe you may just want to see the code again. We have constant edge, document, and so on, edge logs, generating witness. That is, I've said it generates witness. And we require this witness for generation of the proof. Show logs, generated witness. Show logs, generating proof. Logs, generated proof. And then results. So this is, and of course, that is what it does. Generating that witness and then the proof. So, and again, I've showed you where to paste it. Now here is the detailed explanation of that very code. The first part is that it gets the edge from the input. So, and that is what I would say, constant edge document get element by ID, age, value. So this line is meant to get age from the input. So it gets the value, number. Value means number. So that means you're not writing a word. It will not allow you to write a sentence. You can only put a value, a number. So the user is able to insert there to input if it's 20, and then it will accept that 20 must be a number. You don't write it in words. There will be no space for that. The other line, show logs generating witness, constant witness, await, Noir, execute, age, and so on. So this runs Noir and gets the witness. That is the command that performs that role. Runs your Noir program using age as input. Then two, the result of this is a witness. This is a private value, proving the computation is correct. So from the very start, our circuit there was age was private. So and that continues. So this one runs that Noir program, and then the result of that compilation is that there'll be a witness, and this witness will be private value. Then it shows a message before and after you see what is happening. Now, so the other line, show logs generating proof, constant proof, await backend, witness, show logs generated proof, and so on. So this one asks Barretenberg to create a proof from the witness generated above. Then after that, it shows a message before and after. Now, when we be doing it physically, now you'll be seeing it, how it does and what that message is and so on. Then it displays the proof. Displays the proof in the proof results box of your web page. Now, so that proof, you may want to affect the way it's generated. For instance, you may want to, the format in which it is and so on, but the proof will be generated. So you want it to be in JSON, and so on. So it depends on what you want. So that means you can modify this code to produce what you want. But what I know is what I've given you will generate a proof. But you may want to have the proof in some particular format, which means therefore you have to again rework on this code to be able to produce that particular format you want. Now, so this is just, I've put all of them together. Of course, it said we're just pasting them inside the index.js. It began with a small index.js, and we've been building on it. And the reason was that we do it bitwise so that you're able to know what every bit does, the role of every bit. Okay, I hope the screen is still clear and you can still see. Of course, this structure may expand it, add a few things here and there to make it bigger and so that it can perform several roles. But just for the sake of a web app, this structure is enough. Okay, so I was just looking at what we had earlier. I wanted to look at where we came, our index.js, and we see how it has grown. This is what we had from the start. We did not have the 3 lines above that are supposed to import a few things that we mentioned. And inside our try, where this was nothing, and see inside the try there was nothing. I only return Noah goes here. And it's at this point that we are inside this try that we're creating and pasting several of our codes. So it's just inside here that we're creating and pasting most of our codes. So we pasted this one inside there and you said what it does. Okay, let's look at bundle and sub. Now, so this is to assist us create byte config file. And this is byte config file is important because we'll be using it for easy bundling. So for you to create it, you just say touch byte.config.js. Now, once you run that command, you're just running that in the terminal, it adds config to include WASM models. So you just copy this and paste inside that. Because of course, when you run that, it gives you where to paste. So you copy this and paste. Now, so after that, you're almost done. You want to run yarn dlx byte inside the terminal. And when you run that, it prints visit local wholecaster base. So it runs, and therefore it means what you run can be accessed at this. After it runs. You can now go online on your web, www.something https this, and then you'll now see your browser and everything there running. So you just do yarn dlx bit. So you can go there and now see where to put your age and verify and so on, because you want to prove that you are above 18. And when you try to put 15, it will not run. But if you put there 18 and above, it then runs. So again, just look at it. So that means our structure has grown. The structure must have grown by now. This is what it was. We just created config byte.config. So when you run this, it creates another folder. And that folder, you then paste this. And this will then assist us to build and then serve, to bundle and serve, bundle and serve. So you can run now yarn dlx byte inside your terminal, and when it begins running, you can now go to your website and on this link and see, then follow the generation of the proof. But before going there, we want to do a few things for verifying the proof. You add the verification at the end of your try block. Our try block, we had pasted a few things and we still have some space. So at the very end of your last paste, you add this. Add the verification at the end of your try block. So this code show logs, verifying proof, constant, const is valid, await backend, verify proof, show logs, and so on. Now place this verification code at the end of your try block right after you've generated and displayed the proof. Place after show results. So this I'm just describing where you're supposed to place it, the exact place. Now this is our try proof. So after you paste it, this is how it should look like. Here, this was for verification. So our last for generation of the proof ended at this point. So when the generation of the proof ends, we now want to verify. This is where you paste it. And here it is. For me, I've pasted it here. So I think what follows, because I have already done this, I may now want just to show you mine so that we run it together. Just a minute. I'm just trying to find out where it is. Just a minute. Oh, let me just my WSL. Let me open it again. I was using it for something else. Okay, my WSL is not responding. Okay, so here it is. Um, let's begin with our main, just to verify. So, of course, what we say it is. Say we just be use a very simple circuit just to delete our target. And then let's create it again. I'm going to compile. Oh, just so we're supposed to enter circuits first of all. Our NAGO is inside the circuit, so we say CD circuits, CD circuit. Okay, then NAGO compile now. It has just compiled. And we have our targets, and inside we have a circuit that just, and this is what is inside that inside.json. Okay, so we began by creating our circuit and then src, the main. We just compile our NAGO compile. The next thing we did was to create our HTML. This HTML. And this is the code we pasted here. This is the code we pasted. So you can again just copy it, confirm it's the same as the one I given earlier. The next thing we created was index.js. Index.js. And we've just been adding things one slowly by slowly. We added this imports at the top, and of course, we explained what their role is. After that, we came and created this, pasted this other command for edge entry and so on. And then the one for generating the proof. Then lastly, for verification of the proof is what we've just done. I had said we also require a package.json, and mine has just this. And then we've also created bytes.config and pasted this command. And of course, I've said this will assist us in the web. The other thing is just a small readme if you want to describe how your circuit, what your circuit does and so on. It's not very part of what we are doing. Mine was just to show you what codes we have. Now, these are the things you see like in Node config. I was installing package.json, so they are just automatic. Okay, so that is how our code is supposed to look like. Okay, sorry for that. Can I again share it? So I just wanted to run it. Oh, I've run it inside the circuit, so I should have done it in the main route. Let's just complete. I should have done it inside the main route, not inside circuits. Okay, but there's something it's saying, even if I run it in the wrong directory, there's something it's saying here that you can visit here to see whatever is happening. So let's just copy this. Let's copy this link and go to the browser. So we just leave it running the way it is. We leave it running. So what I'll do, I'll just stop sharing so that now I can share the browser. I don't know whether that is what I was supposed to do. Stopping that and then sharing the browser. But where is the browser here? There's a net. So I want to share browser so that we paste that link and see what is happening there. Okay, so I've succeeded. Here's the browser. So I want to paste that link here. I think you can see. So let me run it and see what it says. Did I stop it? I was supposed to be to say something. A new page. No, I don't think. Just go back and see. Was it supposed to be running? Okay, let me now run it in the right place. I guess because we had run it in a wrong place, that could be the problem. So let us first of all stop this. To stop it, we hold Control and C. Okay, that stopped. Now let's run it here. Just give it time. I hope that is where the mistake was. But what you saw is that it was connected to the web from the commands you are seeing at the bottom. It was giving you a link from where you can now go to see the proof, verification, generation, and so on. Okay, let's again try. Let's again go and try where we're supposed to be seeing it. And again, we're going to the browser. I just want to share the browser. Or is it? I don't know whether it's this one. I think it's here. So I paste my command. Let me see. No, it's this one. Now you can see what it has written here. Noir app. There is enter age, submit age. I think you can see what I'm sharing. Logs proof. Let's try to submit wrong age because this person was supposed to prove that is above 18. Let's try and type there 17 and say submit. So this may not even go to completion because we entered the wrong age. We entered the wrong age. So this process may not go to completion. Let's raise it to 19. Now this time we submit for this agency. Now you can see this one is now working. It says generating witness, generating proof, verifying proof. Then proof is valid and the proof is here. So the proof has been generated, it has been verified and is valid. And you can see the proof. That's why I said in your own code, you can try to make it such that the proof is in a particular format you want. Like mine, you can see I cannot see it properly. So I need to rework on it so that my proof is in a way that is friendly. Now let's try another edge and submit. And again, there's a different proof for that again. Different proof for that has been generated. So let's try 90. Oh, we submit. And you can see a different proof for that. These proofs are different. This one was for the first edge, 18, was it 18? This is the second edge. And now this is for the second edge. We've done, and see the proofs have been verified and generated and verified thrice. The first one, the second one, and then the third one. So each one of them has a proof here, and all these proofs are different because we are dealing with the different edges. Let's try 18. Let's try 18. Oh, there's something I wanted to find out. What if I was to do 90 again? Will I get the same proof as the one I have already? Problem is we are not able to see it's going further and further. Now, this was 90, earlier 90, and we've just put another 90, and you can see the proof is the same because it's the same edge. So every time you put the same edge, you expect the same proof. So you cannot have different proofs for the same edge. And it's zero knowledge. It's private. So this is what the verifier would be seeing. But on your end, you just entered your edge. And so the verifier is just able to see that you're above 18. The verifier is able to see that you're above 18, is able to see the proof and verify it. But it's not able to see your actual age. And this is the beauty of zero knowledge proofs. So I think that is what I wanted us to cover today. That you learn how to do web app, and you've seen what we've done. You've seen how we generate a proof on our web and how we verified it. And you can see our proofs on our web. But what you can do is you can always modify this code to do more than this. For me, I'm doing this one locally, but you can now do it to do even real live, real world integration. That's what you can do. Thank you. Thank you for attending this class today. In the next class, we try to improve on this and do more other functions. Thank you.